watching. I'm Pat LaChapelle. I'm working more on my stock market model. I work more on this project every single day. So tune in if you're interested. Subscribe if you're interested. If in stock market models, quantitative market models, Python coding, AI coding, any of that stuff, go ahead and subscribe because I work on it every day. So before I get started, I'm going to go over where I'm at, what I'm up to, and what I'm going to work on today. I'm going to start with an overview of the project as a whole. Whoa. Oh, wrong PowerPoint. Now, let me show you the outline for the project real quick. So, this is basically what it looks like. So, here's the whole thing because it's kind of hard to see with my face in the way, but I have two goals. So the first goal was to beat the S&P 500 by a significant margin and make money in all regimes. So if the S&P is going down like it is currently, I want to still be making money reliably on a general basis, like week to week, month to month. Every month should be positive. Most weeks should be positive. When the S&P is going up, I want to be doing significantly better than the S&P, 2 to 3 times as good. So those are my goals. Now I'm writing all of this in Python. This is a quantitative model to predict returns in the stock market. So I'm generalizing all this in Python and making it so that anyone can run the same code that I'm running. So the actual model that I'm getting can be defined in well under 100 lines of code. You can even, create a universe, create a model, train the model, and see all sorts of outputs in under 50 lines. So if you're interested in that, go check out the GitHub. The link's in the description. It helps me out a lot if you star the repository, watch the repository, and follow me on GitHub. So this is the outline. So I have stock data going back to 2011. I've gotten it for free. The link for that's also in the description. If you want to know how to get it onto your computer, I have some instructions on the GitHub, and I also have some scripts which will easily put this into a format that's viewable by pandas rather than it being a SQL database. It's a adult repository. That's basically GitHub for data. So that lets you make a SQL database on your computer that lets you query the database. If you just want to get all data into a pandas data frame, I have some scripts that do that. So the first step is to isolate a stock universe. You don't want to train the model on all stocks. Things like penny stocks and low volume stocks, those aren't going to be any good for the model. There's all sorts of other things going on with those. Low volume stocks in particular have high slippage, so you're going to lose a lot in fees. And just, gaps in the bid-ask spread is going to cost you some money. You don't want to use things like ETF because those have fundamentally different price movements from common stocks. So I'm isolating the universe to just common stocks, real estate investment trusts, and ADRs, which are foreign stocks listed on the U.S. market. Once I have a good stock universe, I'm using this to train the returns model. The returns model, basically, I have all sorts of features that you can put in. And you want to predict things like the log return for the day, log return for the next 5 days, probability of a positive or negative return. What else? Return relative to the market average, return relative to the sector, things like that. Once I have a really good returns model, I'll talk about the metrics to assess whether it's good or not in a second here. I'm going to implement it into this portfolio model. So this is a larger model. It takes the output of the returns model. It also takes into account, like macro features, basically how is the market doing as a whole, what are interest rates doing, what's the volatility index doing, and then decides how to apportion money in a portfolio based on all of that. So this is where I was at the end of January. I started this project at the end of last year, really like December 29th. So it's been the project of the year, basically. for me, not in general. It's not won any awards for Project of the Year. Um, but yeah, so this is where I was at the end of January. I had a good model, but it basically wasn't working well. I got some portfolio strategies that worked on this, but they were very fragile, so I needed a better model. In order to do this, I needed to restructure the code base so it was flexible, diverse, and anytime I wanted to add something new, I didn't want to make a whole new script. I just wanted to, write a few lines into my existing scripts and utilize it. These are all the features and targets that I added. Um, what else? So I got what I initially thought was a really good model working. You see, so these are the metrics I'm looking at. Um, Here, information coefficient, standard deviation of the information coefficient to information ratio, and t-statistic. And so these last four metrics are telling me how stable the model is. The information coefficient is telling me the predictive power of the model. And so at first glance, you think, okay, this is a really great model. It's working really well, but it has a lot of problems. So the first problem with this model is the universe was including all assets, not just common stocks, REITs, and ADRs. The second problem is I found out a couple of days ago that I'm calculating the feature engine wrong. This is getting features from the universe class so that stocks that have been dropped out of the universe for a month and then rejoin the universe. These long trailing features, like 60-day moving average, for instance, is going to be incorrect because the model didn't, or that ticker didn't exist in the universe for a month. So, for instance, if you imagine Apple started the year in the universe on January 1st, it was included in the universe. I'm updating the universe once a month. And then February 1st, say it was excluded for all of February, and then it was added back into the universe for March. If I'm getting the 60-day moving average at the end of March on Apple, it's going to go back to the beginning of March and then back to the beginning of January because it wasn't included in February. So that's the second problem with this model. Um, Actually, oh yeah, and then the third problem with this model is that when I changed how the data was splitting, it stopped performing well. When I did a walk forward analysis, I saw that the performance of the model fell off with time. And so that problem that I discussed earlier, the universe problem, is really what I'm focusing on today. I need to calculate features in a reliable and robust way. So yesterday I implemented some code to do this, and you see obviously something is wrong here. Actually, the information coefficient is negative, so it has inverse predictive power. And actually, the inverse predictive power is so high that this would be beating my metric if I take the absolute value. So if I just bet against this model, I would be having a good strategy. So something's obviously wrong here. And that's what I'm going to work on this stream. My goal by the end of the stream is to have the feature engine calculated in a correct way. And then I want to reassess the models that I have working with the feature engine that works. So that's what I'm working on here. Yeah. So yeah, I gave it this, gave Google Gemini this request earlier. So let's see if we could troubleshoot it. I'm going to plug in some music while I work. Yeah, comment something interesting in the chat if you want to talk. Or also comment music suggestions. All right, so here we go. Let's go through what it says. So I gave it this request while I was at work. Oh, okay. Why do I get this error? Okay, so let's I didn't give it. I thought I gave it to this. Gave it this thing earlier. So, um, okay, that is not it. I guess maybe I gave this to Claude. So it's Claude say. The model return negative IC. Let me carefully trace the shift in alignment logic. Negative IC usually means look ahead bias or an inverted shift. Let me look at the logic carefully. Shift equals is less than 0 is lag features. Shifts values down by 1, meaning today's row gets yesterday's value. This is correct for lagging features. You want to use yesterday's feature value to predict today. Shift is greater than 0. Do the negative shift. So that makes sense. It's working. So it's using a fixed forward window indexer to sum the next 5 returns, meaning the value at row t represents the cumulative return from t to t plus 5, and with shift equals 0, it stays at that row. The features have shift cross-sectional z-score. The forward return gets z-scored, but I need to figure out exactly when that transformation happens. Oh, so this is it thinking. I don't want to read all of this. I just want to read the conclusion. Trace through the entire compute pipeline. The feature target alignment is actually correct. There's no look ahead bias in the shift mechanics, but I found 2 real issues. Calc forward return has no min periods guard. A one-day return cross-sectionally z-scored against when using a base index or subclass. Pandas defaults min periods equals 1, not window size. This means the tail of each at the tail of each symbol's time series you get partial forward returns. So that's not going to be that big of an issue, but I didn't know I had that. Hey, Goyat Dikshant. I thought you were using AI for coding and planning instead of Gemini. Gemini is AI. Oh, you mean the AI? Do you mean this guy? Oh, I closed it. Did you mean anti-gravity? I was using that. And then I was using Claude Desktop. Neither of those seem to like think really well. It's like I feel like it's trying to do too much. And all I want to do is, write a function at a time. So I'm going back to using this guy. Using the web interface. Okay, so this is an issue, but it's not going to be that much of an issue. Cross-sectional z-score computed on wrong population. It's using the full raw OHLCV. Then at line 1162, you merge back to the universe. This means both your features and your target are z-scored against a much larger population than your universe. Your max forward buffer only considers you're getting lucky that the calendar day buffer happens to exceed 5, but this should explicitly account for lagging features. Oh, try Codex. I mean, is that going to be better than anti-gravity or Claude Desktop? And why? That's what I want to know. Move the CSZ score computation to after the universe merge. Okay, so let's try both of those. Feature engine. Issue 2. Your phase 3 transforms. Compute CSZ score. Window. Forward return. Alright, so first let's change this. Calc forward return. I also sued Claude. Oh, you also used Claude Codex. Wait, what do you mean? You're saying Claude Codex seems to be consuming a lot of tokens. Oh, you have raw data going back to 2008? Did you get it for free? If so, could you share your data set maybe, please? Because that would help me a lot. I would love data going back to 2008 because I want to include the 2008 crash, which is the best crash we have in data. I need some really good crash data. And since 2011, it's basically been a bull market with a few interruptions. But yeah, how did you get your data? Or if you don't want to share it, just generally tell me about it. I'm interested. Also, are you using paid data? Because that's one of my constraints. Is everything I use, I want to be free so that anyone can do it. You liked Codex more than Claude. Um, are you saying Claude inside of Codex uses a lot of tokens? Okay, so what's the function I want to change? Calc forward return. One of two. So it is in here, but it looks different from sclose log return indexer, sclose log return indexer, forward return. Okay, so let's make this forward return. Min period. Oh, so we basically just add an argument to forward return. Min periods. Min periods is equal to time period. Okay. Now this is going to be more of an interesting issue. Cross-sectional z-score. In order to fix the transforms, should I move all of them to after the data frames are merged? Move the entire phase 3 transform block 1067 to 1157 after the merge at line 1162. Okay. So let's find that here. What, buddy? It's okay. All right, so let's go to 1162. Okay, so this is the merge. So it's phase 2. Group by loop, time series features. So what does continue mean? Does that mean just escape the loop? What, buddy? Codex, you just pay... Oh, let me get out of this. Oh my gosh. You just pay $30 a month and you can code well, don't have to worry about tokens as much. It's manageable. Oh yeah, well that sounds like something I don't want to use. If it the problem is all the coding tools, they're trying to think too much. Um, I find it works way better if I just like give it, write this function for me, or here's my code. What's the issue? Or here's my code, add this function. Like when I was using Claude Desktop, it's like generating a plan and all this stuff, and that's like way too complex. I can do the high level thinking. I need it to basically be a software engineer. I think of it as I'm the manager of the software engineering team, and the AIs help me as software engineers, but they're not really useful with the high level thinking because they run out of requests. The data I got is from multiple sources: Y Finance, FinHub, that are free, paid for only Alpha Vantage. So the problem with Yahoo Finance is I'm pretty sure they don't include things that have been delisted, right? Does Yahoo Finance include delisted things? Because the problem is my dog keeps whining. He wants a WALK. But if it doesn't include things that have been delisted, then it's going to have a survivorship bias problem. FinHub I've used before, but not recently for this project. Let me see if I give him a bone. I'll be right back. I gotta go get a bone for my dog. And I'll see if that'll get him to quiet down for at least. I just gotta finish the stream. Hop up. There you go. You want a busy bone? Good boy. So I gave him some bones. Let's see if that gets him to chill out until the stream is done. Um. All right. So let's see. What does continue keyword do in Python loop? Not sure. I'm just starting with S&P 500 with commodities and sectors, then add more stocks. But then, how do you get the S&P 500 data? That must be from Alpha Vantage, because when I tried to look up a list of S&P 500 stocks over time, it says this is something you have to pay for. The S&P 500 basically like guards this. Maybe the problem of delisting that you are focusing on is kind of small. But I can't imagine it's kind of small. That seems like you have a serious bias. If you're starting now and you're excluding everything that's been delisted since 2008, that's basically the same. When you're trying to forward project your model and get it to work in the future, um, you don't know the stocks that are going to be delisted in the next 10 years. So if you could, exclude the stocks that are going to be delisted in the next 10 years, that would seriously improve the performance of your model, don't you think? And then, yeah, I mean, that's the whole survivorship bias problem. I don't know. And uh, intuitively to me, I think I'm going to have a real problem if I exclude all things that have been delisted. If I only include currently listed tickers in my data set, I think that's going to give me issues. But what I'm interested in is how did you get the S&P 500 data? Did you have to pay for it? Or oh, you're not saying including all tickers in the S&P 500. You're just saying the S&P 500 itself going back to 2008. Is that it? Um I want to have I like what I like what I liked initially about this strategy is I feel like the more data, the better. So if I could include a broad range of stocks, I'm going to be able to learn a lot more patterns than I am on just the S&P 500 or just things I can get easily. See, focus should be how certain sector performs and stock performs with environment, and I'm not sure what you mean by that. See, focus should be how certain sector performs and stocks perform. I agree. It should be how do certain sectors perform over time. Um, but if it's all tickers that are currently in the S&P 500, then and it's going back to 2008, then that's basically, if you go back to 2008, like, that's saying the future of all the stocks that are going to be dropped out in the next what is that, 17, 18 years. That seems like a big problem, don't you think? Won't that cause a big survivorship bias problem? Have you gotten to testing any models yet, and have you encountered that? Have you tried paper trading yet? Okay, well, I have 5 viewers, so I'm going to take this chance to say please subscribe, like the stream, go to the GitHub, try out the code for yourself, star the GitHub, watch the GitHub, follow me on GitHub, join the Discord. All that stuff helps me out a lot. Except for joining the Discord, I just want to talk about interesting stuff in there. So the continue keyword is a loop control statement used to skip the remaining code within the current iteration. So for I in range 3, if I equals 3, continue. In Python if loop. No, all tickers too that are... Oh, I already read that. Used to skip the remaining code. If num equals 3, continue. Oh, so continue to the end of the if statement. So if not request.transforms, continue, skip this stuff. Okay, so this is where the transforms are applied. So I want this guy not to transform on the whole of the data. Cleanup block, make a list of all final column names. Drop the base columns only if they weren't explicitly requested. Drop NAICS macro. If calls to drop, drop them. All right, so all of this. The cleanup and the transformation calculation. Okay, so then after that, let's do the normalizations. So I fixed the two things. Yeah. There's a Discord link in the description. Yeah, so join that. I want to get, interesting things. I want to just talk about interesting stuff. Stock market, quantitative models, coding, AI, politics, geopolitics, philosophy, religion. Is there anything else I like? No, those are the main things. Art, culture. That's all the stuff I really like that I'd like to talk about. But we haven't gotten any really good conversations going. I'd like to get it to the point where every morning I look at the Discord and there's all sorts of interesting stuff to read. But it's not there yet. But hopefully I stream every day. So hopefully we'll keep adding people to the Discord and get it to a critical mass where there's always something interesting going on. So now we have this. I believe I fixed this. Let's run it. Okay, so let's get out of this. Terminate. All right, now let's do Model Explorer. And let's see how it does. So, let's go back here. And I could say I made some changes to feature engine .py because my model was giving a negative information coefficient of considerable magnitude. Minus, greater than minus 0, or less than minus 0.01. Here is the new script. Do you think these changes will fix the problem I'm having? And then I also want to just look at the data that the feature engine's calculating. Okay, wrong code. Stock market tool, scripts, feature engine, upload, and let's get ready, run it. So I should have more requests now. Hey, Kartik Kana, is that how I say it? I'm good, thanks. How are you? Basically, I found out, what was that? I think that was 2 days ago now. I determined that I have a serious problem with my model. So basically, how I was calculating features was, so I was trying to troubleshoot this. This had two problems. One, the information coefficient goes negative. I should never be seeing that. So the information coefficient's going negative, despite the fact that this model gave, oh no, not this model. Here I'm getting really good results, or what appear to be really good results. So this is the decile analysis down here. This should look like a staircase. It does. I'm neutralizing to sectors. So all mean reversion and volatility features, I'm already adding all features neutralized to the market. But for mean reversion and volatility features, I'm adding new versions of those additionally to the model, which are normalized to the sector instead of the market. So this is on a much more constrained universe because I'm only including common stocks like Apple or Tesla, ADRs, which are foreign listed stocks listed on the US stock market, and real estate investment trusts. And then I'm getting the bottom 1,000, or the top 1,000 by dollar volume, sorry. Excluding everything that had over a 50% crash. And yeah, so that's what I'm currently doing. And I got this model. This looks really good, and it's beating every metric that I'm going for. So I want 0.01 to 0.02 on information coefficient. It's getting that. I want the standard deviation of the information coefficient to be 3 to 13 times the information coefficient itself. I'm getting that. I want the information coefficient to information ratio to be above 0.05 on a daily basis. I'm getting that, 0.15. I want it to be above 0.3 on an annual basis. I'm getting that, 1.07. The T statistic, I want to be above 1.95, and it's 1.32, so it's not quite there. But the T statistic is the least important of these metrics. That's kind of just a verification. And so this is basically doing how I want to do on every metric. But the problem is then when I looked at the walk forward analysis, it seems like certain years it's doing well, certain years it's doing really bad. And the other thing is the walk forward's ending in 2020. So even if it's doing bad, it shouldn't ever end in 2020. And so I determined the cause of this, at least one cause, is that the feature engine's being calculated incorrectly. So, I need to figure that out. And so when I was trying to figure this out, I realized that the feature engine's being calculated incorrectly. So I fixed the feature engine and ran it on this earlier model, Let me show first. Here's the earlier model. The first one I thought was working really well. Um, and so I did it here, and look at this. That's really bad. And actually, if you exclude this first one, it's actually like the perfect inverse of what I should be getting. So it should look like a staircase. Start really low, each decile in order gets higher. Do you read research papers for new ideas? What is your idea generation process? Not asking for specifics, just general framework. My framework, well, so far, what I'm adding to the model. This is a very basic model, so I'm kind of marching forward, trying to get something going with this very basic model. So this should work okay. But the first model I want to do really is all price features and all fundamental features, and then trim it down to things that are really essential. And so this is like it's really complicated, really hard to code. I've been working on it for over 3 months now. But for quants, this is a very base level model. It doesn't include anything fancy, doesn't include anything specific, just base level quant features. So the only research I've really done so far is using ChatGPT, or I don't use ChatGPT, that's useless. But Google Gemini Pro and Claude. And I basically ask it, what do I want to add to the model? How can I add it? How do I prevent look-ahead bias? How do I prevent survivorship bias? How do I prevent overfitting bias? And taking its suggestions, kind of sometimes I look around on the internet to make sure, this is making sense. Try to understand the features, but that's the bulk of my research process. I have used stuff from a few papers, like here. Okay, so the AIs aren't always perfect. So when I asked Claude, what are the features I want to calculate, it did give me good features that I verified elsewhere. But it also gave me like the wrong goals for some of these features, specifically the standard deviation of the information coefficient. So it's telling me here that the standard deviation of the information coefficient should be orders of magnitude smaller than the information coefficient itself. Now, this is true generally for machine learning models, but it's not true for stock market models, because stock market models have a really high or have a really low signal to noise ratio. So there's a bunch of noise in there, and the standard deviation of the information coefficient is never going to be great. So although this is true, the goal of standard deviations orders of magnitude less than the information coefficient, that's true for machine learning models in general. It's not true for stock market models because there's so much noise. So I found this paper which basically did an analysis of successful strategies that have been published. And they give a table where it's showing the information coefficient and the standard deviation of the information coefficient. And so you see here the standard deviation, this column, is never smaller than the information coefficient at all. It's always larger. And let alone being smaller by orders of magnitude. So in this paper, it says the standard is 3 to 13 times. The standard deviation, as a rule, in all of these studies, is 3 to 13 times as big as the information coefficient. So I kind of updated my goal for that. These are my references. I've used 3 features. This is a good paper, Bisdulis. I guess it's recent. It's from 2 years ago. Asset forecasting with feature engineering and transformation methods. He gives a really good overview of a lot of things. Like, for instance, when I'm tuning the hyperparameters, how many iterations do I want to run through to optimize the hyperparameters? I was using way too few. He says use about 500. I find that the performance doesn't really increase at all if I go above 50, but that was good for that. He gives like a good overview. This Kuhn and Johnson, that just basically is a method for feature reduction. But it turns out there are better methods of feature reduction for stock market models. So there's a lot of things that apply to machine learning models in general, but since the signal to noise ratio is so low in stock market models, they don't always necessarily apply to stock market models. And also very important, how many monsters have you had today? Well, this is my only... Is it my only monster? No, I had another monster while I drove to work. So that's 2 monsters. And then I got a coffee at work. So I drink way too much caffeine. I need to cut back on that. But yeah, good question. All right, so this should be okay. So real quick before I do anything else, I want to look at the model data. So let's say model.data. And I'm going to save it to a CSV so I can access it while the model runs. And let's save it. Ooh, not CSV. That's going to be really big. What is that? 4 million rows. So we'll say to feather. And we'll do sample from FE feature engine and today's date. So 2026 04 02 dot feather. Okay. And now we can continue. And then let's go look at that. Real quick, let's see, did this give any suggestions? There are two distinct bugs. The attribute error, this is a simple pandas data type issue caused by how PyArrow loads data into memory. Negative IC, this is a massive hidden mathematical bug in your calc forward return function. Your target is accidentally looking into the past, causing your model to buy stocks after they have already spiked, resulting in immediate mean reversion. Fixing the attribute error. Attribute error. Can only use DT accessor. Wait. I already fixed that. Force the explicit data type casting immediately after the PyArrow load. Force the explicit data type casting. Okay. Fixing the massive negative IC. Your new script correctly implements the variable swap and the inner merge to fix the time series continuity. However, your model is giving you a negative IC because your target is mathematically misaligned. Calc forward return. Your code calculates log return for Tuesday, which is log of Tuesday divided by Monday. The fixed forward window indexer sums up the log return. The sum of those sequential returns equals next Monday divided by this Monday. On the Tuesday row of your data frame, your target is measuring the return from Monday's close to next Monday's close. On your Tuesday row, target is measuring the return from Monday's close to next Monday's close. Because your target includes the jump from Monday to Tuesday, your model easily predicts high returns. When you run walk forward, your model says buy this stock, it has a massive 5-day return, but that's not the case. A forward return should be purely future price divided by today's price. You don't need rolling windows or indexers at all. Yeah, that's true. The new architecture in your script is excellent. The inner merge perfectly enforces your universe, and PyArrow will keep your RAM safe. Alright, so let's see how it performs with the other. I might need this guy, but what the hell? I have the debugger again. Continue. Okay, now it's going through the model. It's basically how to construct a volatility index for any index that does not have. Wait, what do you mean? What is? I'm confused on what you're referring to. It's basically how to construct a volatility index for any index that does not have a volatility index from options market. But what is? What is its? What's its referring to? What is the it here? It was primarily aimed at developing market indices like Asian ones, from where I am, since the market are developed enough so this works like a proxy. Aren't. Yeah, so what is it? Do you read research papers? Yeah, what's the it you're referring to? I'm missing something. Did you... Sometimes if you put a comment in the chat which contains a link, YouTube will block it. So maybe that's the problem. Did you put a link in? But I'm not sure what the it is that you're referring to. Yeah. But tell me, because that seems useful for me. I need to do a... it would be good to get some volatility index on every stock. Or like sector volatility. That would be really useful for me. Okay. So this guy's going, but it's taking a really long time. Do I do the merge after? Oh no, the merge is before. Universe DF, what is that? Yeah, I guess I need to see how the model works before I implement this. So this is at trial 6, so it's taking a long time to run. Oh. What the fuck am I doing? It's because it's running 2 models at once. So I don't know which one I ran first, but let's get rid of that guy and we'll see how it goes. Alright, now let's go here and let's go look at that data that I saved. So cd data, cd dot dot, cd data, ls, and let's go Python. Let's import pandas, and then let's say df. Oh, import pandas as pd. Then let's say df is equal to pd.read feather, and let's read. So I saved it as today's date. Is it not saved? Did it save somewhere else? Let's get out of here. CD Explorers, did I save it in here? Okay, maybe it's not loading? So let's get the most recently changed. Really? I must have not saved it. Explorers. Oh, here it is. So it's in Explorers. Okay, import pandas as PD. Let's say df import os. No, not just import. Import os, then let's do os.listdir. Yeah, so that's it. Fname is equal to os.listdir of minus 2 is the index we want. And then we'll say I for I in fname. Okay, then df is equal to pd.read feather of fname. And then it's taking a while to load because it's a big file. Trial 39. Yo, Kartik Khanna, I think is how you say it. Tell me what you're talking about. What is a how do I construct a volatility index for any index that does not have a volatility index? What was primarily aimed at developing market indices like Asian ones? My eyes are dry. Come on, let's see how this works. We're at 45. We just have to go through to 50. So 46. Do 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 do. 49. All right, one more trial and it'll be done running. And we can see how it performs. Can we connect on Discord? It will be easy to explain stuff. Yeah. Just join the Discord. I'll go there right now. Discord. Okay, good. It finished running. So this is the feature importance. We should have regimes at the top, as Sir Night Night, one of my viewers, says. The guy knows a lot and is very helpful. We now have a positive information coefficient. Hey. Positive information coefficient. And it's looking good on several metrics. Nice. But I need to look at the features to make sure that they are correct. So let's go back to looking at it. So we have df. Let's just get Apple. Len of df.date.unique. So this will give us how many days are in the data frame. 2374 days. 2,374 days are in the data frame. Okay. Are you Lycan DK? Lycan DK just showed up, it says. I just went off the stream for a couple of minutes. Did you check out? No, oh, okay, that's it. So you gave a link to the paper. That's the problem. If you give a link in the chat, YouTube censors you out. So tell me, what's the name of the paper? Kartik Khanna. If you tell me the name of the paper, I'll look it up because that sounds pretty useful. So there's 2,374 days in the data frame. Now, Apple is equal to df, where df.account symbol is equal to Apple. Okay, nice. Okay, I'll give you a thumbs up. Thanks for joining. Lycan! Exclamation mark. Yeah, somebody, oh, it's Sir Night Night, the guy who has all the helpful suggestions. He said I should make a Discord, I think because one stream I was blabbing too much about ideas. He says we should make a Discord to discuss ideas. So I did. So I want people to join it. Talk about stuff. Anything you think is interesting, just throw it in there. We could get a conversation started. I think most things that people comment on here are interesting. So we're all interested in kind of similar things. So just start talking about it in there. We could talk about it. There's a bunch of smart people in there that have a bunch of good ideas. So now let's do apple.date.unique. So we have 2,374 days in the data. We have 2,087 days of Apple data. So maybe we could try a lesser known stock. So let's see, is Ford in here? Good. Let me look that up. Just a sec. Let's figure. So this gave really good returns. I want to make sure, or this returned really good results. I want to make sure I'm not fucking anything up here. No, that shouldn't be Apple. We should call this F for Ford. And then we can do f.date.unique. 20. So Ford is always included. What's another? Maybe we could do Pfizer is gonna be pretty popular, right? 2371. Maybe we could do Keurig Dr. Pepper. $21.45. So what's been dropped out? I need to find some ticker that's been dropped out. So I guess I could use Apple. Apple. So we're gonna say key for keys in apple.keys if key is equal to if t in key.split on underscore. Key for key in apple.keys. So now we'll do apple. Dot. All right. We'll say this guy, then we'll call that, make a variable, say my key, or just t for target key, and then apple of t. Apple apple dot date 21518. So well, we do have data going into February, so that's good. Let me document this. Fixed feature engine code model 12 now gives good returns. So let's put that guy in, and then let's put in this. Not returns, results. So like I said, this looked really bad. It was almost the inverse of what we wanted, if you remember, if you're around when I said that. Now if we look at this, that's really good. So low, higher, 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 lower. It's okay if in the middle it's not perfect. Higher, 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 highest. So top decile, bottom decile, or the highest magnitude. This looks like a really good walk forward. Now, here are the goals. So let's put those in here and assess how we did. So we have information coefficient. Standard sharp is really good, one almost 2. So let's do it goal, insert column to the right, and move that bigger. We'll call this result. So information coefficient, we got 0.013, 103. Standard deviation, we got 0.096. Both those are good. I'd like the information coefficient to be better, but that's a pretty good result. Real quick, there's 5 people watching, which is a lot for me, so let me take this chance to say please subscribe, like the stream, go to the GitHub, check it out, download it for yourself. Let me actually add this change I just made, which made the feature engine work. Hey, NGK. Yeah, isn't that great? I kept hitting my head into the wall, but look at this. This is beautiful. Just what I'm looking for. So we're on the right track. I think the next step is going to be implementing fundamental features, but before I do that, I'm going to go through. I know that I'm getting better results when I'm including the sector normalization for mean reversion and volatility features, so I'm going to do that. But real quick, let me, this is the other repository I was working on today. If on the off chance you're working on XUV data, also go to my GitHub. The link's in the description, and you can. I'm working on a tool. It works right now. I just need to add some good features that are useful for it. So, if on the off chance you're working on XUV data, download that. So clean analysis. Okay, so we fixed this. Columns to keep. So fixed model to work with new feature engine. Okay. Fixed feature engine. To generate from all data instead of, yeah, didn't I say something in the Discord? Thanks, Lycan DK. Oh, there you are. Hey, let me know when you are free. I'm not going to be free tonight because every night I do this. It's late at night here. I'm in California, USA. So it's this time is actually wrong. It's from when I lived on the East Coast, but it's almost midnight. So every night I finish the stream, I take my dog for a walk, WALK, so he doesn't get excited. I gave him a bone, so he's kind of focused on that. And then I go to sleep. So I won't be free tonight, and I won't be free tomorrow morning because I got to get ready for work, go to work. But tomorrow before the stream, I might be free, and then I'll be free, of course, sometime on the weekend. So tomorrow's Friday. So anyway, yeah, that'd be interesting. I'm gonna look at that paper when I run the next model because the models take a long time to run, so I need interesting stuff to look at. So for everyone else watching, when I run a model and I don't have anything to work on, just comment something I should look at that you think is interesting. So fixed feature engine to generate from all data instead of universe. Okay, that's all I need. So now these changes are in the GitHub. Now it's going to work right. You can get these same really nice results I'm getting. So go to the GitHub, check out the repository, download it or clone it or whatever, fork it if you want to make some changes. Try it out for yourself and let me know in the Discord. Buddy, his name's Buddy. His full name, his full official name. I adopted him and his name was Buddy. I liked the name and I thought it would be weird to change his name, so I kept it. But I gave him the full name of Budward B. Dog, because that sounds official. So his real name's Budward B. Dog, but he goes by Buddy. I don't know if that's too anthropomorphine for you. Anthropomorphine, too much anthropomorphization for you. Yeah, so check out the GitHub. If you use it, if you find it useful or interesting, please leave me a star, watch the repository, and follow me on GitHub, because that really helps me out a lot. Helps me get, helps raise my coding profile, helps me get freelance gigs, helps me get coding jobs. So I would really appreciate that. And yeah, also join the Discord. So what was I doing here? I was documenting stuff. Oh, so let's finish documenting the results. So daily information coefficient to information ratio. So now we're getting really good results. Is 0.1068, so that's way better than I'm going for. On an annual basis, it's 0.7582. That's way better than what I'm shooting. Well, it's twice as much as the minimum, so that's pretty good. T-statistic is 0.9323, so not great, but not terrible. Okay, and now... Okay, so let's say how we're doing on each. So this guy is good. So let me make it green for good. Format. Oh. Yeah, I guess I could make the whole thing green. Solid fill, green. Standard deviation's good. So make that guy green too. Daily information coefficient to information. Oh, so all these are good actually, except for the T-statistic, which actually is the least important. I don't even really care much about the T-statistic. If it's not hitting that, I don't mind. I care about the other metrics. T-statistic is kind of just a check. So, this looks really good. Is there any way to make the dividers black? I don't see it. It's fine for now. Okay, so now let's run the model again. Yes. Well, he's never had a Bud Light, but I bet he would like it. Some people give their dogs beer. I'm worried. He's tiny. He's 12 pounds, so I don't know. I think that might not be good for him. Okay, now let's run the model again. I guess, so let's look at the features that are in here real quick. So apple.keys. Log low. Okay, so for key in apple.keys, print key. Okay, so we have log return. So let's say apple dot log return dot, how do I get a moving average? I think it's rolling dot mean. Pandas get moving average on column. Yeah, dot rolling dot mean. So we'll say log return dot rolling dot mean. And let's do, I guess let's import matplotlib. So we'll do from matplotlib import pyplot as plt, and then plt.plot. let's show the apple.date, apple.log return, and then label is log return. Okay, now let's plot plt.plot apple.date, apple.log return dot rolling. Let's say, so we have okay, so let's say, let's print the keys, which are moving average crossover. For key and keys, we'll say if cross over in key, print key. Okay. Then we could say, so we're plotting that. Now let's plot apple log return. Now let's plot apple.rolling.window, rolling, and then as an argument, window is equal to 60. Oh, moving average crossover. Rolling window equals 60 dot mean. Oh, apple dot log return. And then we'll say plt.plot, one more, apple.date, apple dot, and then let's just paste this guy in. So what data range, window is 60. So, but I shouldn't be using the cross-sectional transformation. But let's see, that should only improve the model, right? Apple dot that guy. But let's just see how it looks. Plt dot show. Y is the y-axis dates. So this is the, yeah, whoa. Cross-sectional z-scores returning a date. So let's see if we could forget about the green. So there's no data here. I guess this is kind of hard to check. Let's go here and run the Explorer again. So let's say, does removing neutralization on MA crossover improve results on model 12? So let's go to Model Explorer, test Model 12. Moving average crossover. Remove the transform. I guess I'll just comment that out in case I need it for some reason, but I can't wrap my head around why I would possibly want to neutralize that feature. And let's run it again. Okay, so now let's go look at that paper. Do you have ATR involved in this? No, I have no idea how to incorporate that. I I mean, okay, so you can say, look, I still have that, I did have it pulled up yesterday, session close. Don't I have that still? I had the thing we were looking at yesterday. Oh, I guess I don't have it anymore. Well, alright. Really? Do I not have it pulled up? What the hell? Yeah, I guess not. But anyway, I forgot the exact thing you're looking at, but it was basically a proxy for the S&P, right? So, trading view. Oh, here it is. So, this is the example you were talking about yesterday. So I can see, oh no, that's on the 23rd. So we were talking about the 31st at 12:30. Yeah, this one. So okay, we see there's a spike in volume. You can find that easily. Calculate spike in volume correlating with a big spike in price. You know, you could just say it moves over X% in price. Okay. That would be easy. Standard deviations, if it's this many standard deviations over the average, and volume is this many standard deviations over the average, call it a, what do you call this? A gap up. So I guess I could say this region's the average true range. Yeah, you know, that's complicated. I need to really think about how to incorporate that. But that's going to be the next step. So basically, I have price data. You know, this is fairly complicated. I've been working on it for 4 months. It's complicated for me. See how price came into that fair value gap? Yes. And then the market decided, yeah, so that is exactly what happened. The problem I have is we can say, okay, we can tell that's going to happen again. But I think what my coworker was doing, his successful strategy is he waits for it to fall into the average true range, and then he sees what the market decides. And then once at this candle, once the market's clearly decided, hey, this is above the average true range, we can reliably assume it's going to return up to this area. So then he doesn't buy calls. Maybe he just buys the stock, um, you know, here and then sells. Maybe you could draw a line. Tell me, is this a good strategy? So we say, okay, we're watching this area for the average true range. I don't understand how to pick out the top. So, yeah, you did call it. um, I don't understand how to pick the top, but I'm going to predict that it's going to fall. What is this guy? Fib retracement, XAB. So people, how do I draw just a rectangle? I guess I can't do that, but I'm going to say, you know, here's the, what was it? Oh, average true range. I do think I have average true range as a feature. I thought it was called something else, like fair value something. Yeah, so we say, okay, this is the area it's testing. We're going to wait for it to fall back into here. Here we see it fall back into here. Now we're saying, okay, is it going to break out of here or is it going to fall back below here? Here it's clearly broken out, so you could say I'm going to buy, and then I'm going to buy to sell. You know, if I put the average somewhere here, buy to sell here. And then you would, you know, basically you see this candle, good to go. Now you buy somewhere in here, and then you sell somewhere in there. Is that what you're doing? Because that makes sense to me. Yeah, fair value gaps. That's right. But I do have our average true range incorporated in the model. But I went through and added. There's this thing called TA-lib. So here the features have been calculated. There's this thing called TA-lib, and it helps you calculate. What are these things called? I'm calling them features, but they're also called like I don't know. What I always think of them as day trading indicators. So it helps you calculate these day trading indicator things in TA-lib, and so I just fed every single TAlib feature into the feature engine, so I'm getting all of those. When I tried removing things from the features, nothing improved other than removing the stochastic oscillator. So I'm keeping that out, but yeah, I'm not sure what a lot of them mean. So like average true range, I'm still not sure exactly what it means. Your entry has more steps than that though. So I mean, yeah, obviously this is simple. It's good that you're using a more complicated method than this, because I was thinking this is so simple. I don't know. The problem is, okay, so you called it. That's true. Let me see. So here we see another. So this is what I'm confused on. You could say, okay, here the average true range is here, but it had this gap up here, and so you say, or no, not average true range, the fair value gap. So now, but this gap up didn't correspond with the big volatility spike, so never mind. Here we did have a high spike in volatility, and so this is kind of a pattern. It ran through here. It's your model, your idea is basically saying, hey, we're going to have to come back to this price and test it. So we flew way up, and then we returned to this price and tested it, and the market said, okay, we value it above. But here, again, we had another spike in volume. This candle. So this guy right here. So is this another fair value gap, and it's going to come back and test this? Because it kind of looks like that's what it did at the end of the day. It came back and it's going to test somewhere in this range. So it went a little bit above the range. Now it's going to come back and test it. Now we got to see, is it going to break out or fall below? What do you think of my analysis there? Now let me go look at the paper that who suggested that? Oh, Kartikana suggested it. So what's the paper called again? Cross-sectional volatility index. Cross-sectional volatility index as a proxy for the VIX on Asian market. Serves as an effective model-free proxy for the VIX. Okay, this is just saying, that's like literally what I looked up. It measures average idiosyncratic variance, offering a robust alternative to implied volatility for tracking market uncertainty and predicting returns, often showing high correlation with VIX spikes during market stress. Yeah, I'm not a robot. Model 35. So we are 70% of the 70% of the way done doing feature stuff. Yes, today left a big fair value gap. Okay, nice. 65.75 to 65.86 and 65.30 to 65.49. So let's see. Which is the one that I found? I found 66. I think it's a little higher than that. Do you use the close of the candle if it's a green candle, or do you use the high of the candle? I guess you use where it shot back to. So that would be 65.91, 65.66 to 65.91. If a candle body passes an area with no candles to the left or right of it. Nice, okay. Let me write that down. So 30-minute candles. Okay, the model finished running, but let me write this real quick. If candle I will use the high if the candle is to the left and the low. Oh, the high of the candle to the left and low of the candle to the right. So if candle passes an area with no candles to left, right, it is fair value gap. Rectangle tool, where is that? I was looking for the rectangle tool. Oh man. Rectangle. Wait. Oh, GAN, GANN. I was like, they have AI? Generative adversarial network. Rectangle. Rectangle. It should be in here, right? Triangle, ellipse. Oh, good, rectangle. All right. So use high of candle to left and low of candle to right. So if I'm doing that, then I'm saying oh, oops. Let's do rectangle, high of candle to the left. So this guy. And low of the candle to the right. So there's that one. It came back and tested it there. Now today, we had another one. So we had this gap up. Really, I'm going to use this one. So from this high to this low of candle to the right is a fair value gap. But then didn't it come back and test the fair value gap immediately here? And then it broke out and said it's robust. So why is it coming back and testing it again? Or are you just betting that it's going to come back and test the fair value gap and you don't know? It seems like here it broke out, whoo, then it's testing, it's another fair value gap, it tested immediately. Does that mean it's losing momentum? That kind of seems to me like it's losing momentum. So that's worse. But it's taking it as a numerical feature. Okay, I'm just going to document this and then put a note in. Because this is going to be kind of complicated, but I need to change it from a numerical feature to a categorical feature. And that's going to be hard. So get rid of that. Now let's put this guy in. Let's get this. So exit out of here. Let's get the performance. Put it in here. Now let's put these guys in. Let's put a line. Insert shapes, line. Okay. So, now let's put a note in here. Insert text box. Performs worse, but vals are 1/0, which means model is taking these as a numerical feature. Do these perform better if they... Okay, nice, NGK, thanks. That hopefully that will get some people talking about what do you call this? I think this is called technical analysis, isn't it? Hopefully it'll get some people talking about technical analysis, if that's the right name, in the Discord. Because my ideal is, so I have this quant model. Ideally, I would get good at this technical analysis you're doing. I'm already fairly good at doing like swing trading with geopolitics and just paying attention to market news. And then I need to get better at long-term investing, but I want to incorporate all of these into my portfolio, and I think that'll make it like really robust. Also, another guy, who was that? Oh, that was Paprika, was talking about the real estate. There's a link between real estate markets. Supposedly, there's a 200-year pattern of real estate markets crashing every 18 years. And when was the last crash? 2008 to end of 07, beginning of 08. And where are we now? 18 years later. So, you know, it's supposed to happen again. We'll see if he's right. The test is coming up pretty soon. So, but there's a book on it I got. So, yeah, incorporating that type of stuff too. It'll make everything more robust. Yeah, technical analysis. Yeah, okay. Well, that's what I said. There's a library that I don't want to think either. I want to run a script every day and then have my code, do it for me. I don't want to be thinking. That's the goal, is you make money from the markets without thinking. But that's interesting because basically I'm feeding in the same features that you're feeding in. You're looking at the features, I'm feeding them into a model, and then I want my model to generate, apportion stuff for me. But I'm not giving it things like the fair value gap, so that would be useful to do. I think actually if I get a really good understanding of technical analysis, I'll be good at, it'll make my model way better. But anyway, so you can see these results. It's worse on information coefficient, worse on standard deviation, worse on the ratio, both daily and annual, worse on t-statistics. So it's worse on every metric. Worse on every metric. Decile analysis looks bad too. So look at the chart at the bottom. That looks bad. So cool. Now let's run. So let's take that out of model 12. I gave myself a note. So let's put this guy back in. And let's do model 18. How does model 18 work? So before I found that model 18 is performing even better than model 12. Now that I've fixed the feature calculations, the question is this still true? Let me make sure I save that. So turn on model 18 and let's run it. So I hope it still performs well when I'm normalizing to the sectors for the volatility and mean reversion indicators. Okay, so what next? Oh yeah, I was gonna look at that paper. And I'm pretty happy that I fixed the feature engine. So after I run this next model, I think I'm gonna be done for the night. So what are the key findings these guys have? I have to make sure, wait for when the debugger pops up here so I can... Oh no, that was only in model 12. Never mind. So show us some plots or tables. Oh, here are tables. This is odd. Display table. Why? Of course, yeah, I want to look at the table. Is there a PDF I can download? All right, let's see the tables. Table, plot. Here's a table. Descriptive statistics on volatility return index. Measures sample period. Descriptive statistics measures sample period. What does that mean? Descriptive statistics of implied volatility index and CSV index. So on the S&P 500, the mean standard deviation 26.25, 13.01. Points, so 76% correlation, that's pretty high. Correlation matrix of volatility return index. So why doesn't it show me these other things? Nikkei, is that the Japanese index? Oh, so those are pretty correlated. But CSV looks like it's working even better. I mean, it's noisier, but look at all the spikes. The spikes are happening before VXJ. So can you use this cross-sectional volatility index to be slightly ahead of the... why isn't this zooming in? I can't zoom in. Gotta use their dumbass tool. So look, this is slightly before we get a spike in volatility before there's a spike in volatility in the volatility index. So I wonder if that could be a good strategy. Here, a big spike in volatility. Are there any spikes? Oh, there's a lot of spikes that don't correlate. But if we say it's above a threshold, like here, it spikes before. So if we, let's make the threshold here. Here it spikes before. Here it spikes before. Here it spikes before. Here we got some spikes, but we would have had to write it out for a bit. That's funny. Well, I probably pronounced it wrong, right? Nikkei, something like that. Oh, well, thanks. Thanks. It is a good compliment. But honestly, this stream makes it easy. I'm such a natural spaz. That's honestly like the reason I started doing any streams in the first place was like almost 4 years ago now. And I did it because I found out I'm really bad at concentrating, to be honest. I'm a spaz. So like I just like my brain floats from thing to thing. Um, and I realized I work way better, if I'm working at home by myself, I just start surfing the internet, spazzing out. I go, oh, what about this thing? Things just pop into my head and I start looking at them and I can't concentrate on anything. I can't finish a project. And I realized if I just go work at a coffee shop, it really helps me. Because if I start surfing the internet or whatever at the coffee shop, I feel like people are going to think I'm an idiot. So it helped me focus, but not that much. And then I don't know, one day the idea just popped into my head. I was like, I could live stream it and anyone in the world could tune into my computer at any moment. And then everyone would really think I'm an idiot for not concentrating. So, really streaming, doing it as a stream really helps me do that. Focus on what I'm doing. Because I start talking, I start thinking about stuff. I did need to do the debugger. Um, but then I'm always aware everyone's watching my computer. So, people are going to think I'm an idiot. And I guess that's just a strong motivator to me. I don't want people to think I'm an idiot. So it helps. Anyway, thanks. That's a nice compliment. Maybe it kind of all goes together because I am a spaz. I can spaz from thing to thing. Okay, so this guy's running. So let's start a PowerPoint slide. Oh, this is interesting though. So, where's Buddy? Where are you, boy? He's whining somewhere. Do you want out? He says, let me out. There you go. Okay, so this is interesting. I'm going to put a note on this in my PowerPoint slide. Can I use CBOEVXJ to strategy idea? Can I use CSV? What's it called again? Cross-sectional volatility index. That above a certain threshold so the threshold here would be like 55. CSV is an early indicator of future movement in VIX. That seems like it could be a good strategy. Don't you guys think? Let's make it yellow. More attention grabbing. Alright, so who was that commented that, man? That's a good that's good info there. Let's see. We gotta give him a shout out. In case you're still here, Cardicana, you might have given me a good strategy here. Oh, this guy's taking a long time to optimize, but that's because there's so many features. So let's add here. Does sector does addition of sector neutralized mean reversion and volatility features improve model 18 with correctly implemented feature engine. That's a long title, but okay. Okay, let's make that guy smaller. Solid fill. Let's make it light blue. Move it up to the top. Hey, buddy. Up. Okay, then let's put a line in the middle. Let's insert this. And I already have it in my head, model 12 and model 18. So let's do model 12. I guess here. Where was that? Oh, these guys. Okay, then let's paste this in. Model 12. Here are the results. Okay. Alright, trial 41. We got 9 more trials, and then it'll be finished tuning the hyperparameters, and we'll be ready to look at the model. So let's see. By the way, if you haven't subscribed yet, please subscribe. Subscribe if you for your own sake, if you want to follow along. I work on this every day. The goal is to have a really good model that beats the S&P 500 and gives positive returns in all regimes. And then I'm also generalizing this code, so not only so that it's useful for me, but so that anyone can implement it. So if you're interested in that, go to the GitHub, check it out, download it, let me know how I can improve it. And it helps me out a lot if you star the GitHub, watch the GitHub, and follow me on GitHub. And finally, join the Discord, because we talk about interesting stuff in there. Trial 47, we got 3 more, 48. Here we are. 49, come on. 49. 50, and let's see what the results are. So what do we want to beat? We want to beat information coefficient of 0.0103. Come on, man. Ooh, it's worse. Market sector. Whoa. What the hell? Alright. Let's put it in, and with a note, there might still be a problem in feature engine. Wait, hold up. Model 18, yesterday I was messing around with it and censoring stuff out. So Model 18. Yeah, I'm not censoring anything out. Let's make this guy bold. Okay, now real quick, I'm gonna do the walk forward on model 12 to see how does that perform. Model 12. Oh, let's turn on model 12 walk forward. Test walk forward is 1, so let's look again at test walk forward. So is this happening on model 12? Good. All right, so let me make sure that's turned on and the file's saved. Take this guy off. Model 12 on, and let's one more time just to make sure. Okay, let's run it. And there we go. So that's going to be it for tonight. Thanks for watching. I made a good improvement. I went from, things were broken, not working, to I got Model 12 working. So it's basically good on every metric. I could improve the T statistic. Really, I could improve everything. But that I could really do with fundamental features. It's performing a lot worse when I neutralize market. Mean reversion and volatility features normalized to sector. So I need to look into that. Am I doing the sector neutralization correctly? But I'm going to leave that for next stream. This is a really good result for this stream. So that's it for tonight. Thanks for watching. Have a good rest of your night. Adios. Market, mean reversion and volatility features.